legendary transformation almost about to finish, and what we have learned, U equals to you have SVN, this is the combined first and second law of thermodynamics, and here we have seen the U equals to TdS minus PdV plus mu V. Then we have H equals to H hat SPN, and we have DH equals to TdS plus VdP plus mu V. We had A equals to Helmholtz energy, which is A TVN, which has dA equals to minus SdT minus PdV plus mu Vn. Then G equals to G hat TPN, which has dG equals to minus SdT plus PdV plus mu Vn. See, I don't have to remember anything. I only remember this much. Automatically I read this. It's actually I don't remember. Don't have to remember anything. It's automatically you know that how to flip the sign and get the answer, and you know what are the things which are the functions. So the problem what I have given, only one problem is remaining, which is U equals to S to the power 5 A B N square 4 to the power half. So we have to express this function, which is G hat TPN. I think that I have given for the home task. Okay. Anybody got anything? Any hands? Nobody did. That means you don't want to study anything. Okay. Given relation, which is U equals to S to the power 5 AB N square to the power half. And then next step is what? What are things you will get? What are my x1, x2, x3? We have m1, m2, m3 will not need. x1 is S, B, N, T, minus B. Next step is what? What to find out? C gets to be C directly. That means you don't study at all. You don't study at all. This kind of problems, in just 3 days you just enjoy. I don't know why I am teaching in the class. M1, that's all? M1, M2. M1 is T, what is equals to rho U by Vn. From here, what you will get? Expression M1? 5 by 2. Yes, hand please. Yes, sit down. 5 by 2. S to the power 3 by 2. 5 by 2 S to the power 3 by 2. 1 by ABN square. 1 by ABN square. 1 to the power half. Equation number M1. M2 equals to, second step again, M2 equals to minus P, rho U, rho V at Sn equals to S to the power 5. S to the power 5 by 2. An square 1 to the power half. Or you can actually directly, I can write P from here. Minus P I won't write, I will write P. I got the expression 1 by 2b to the power 3 by 2 S to the power 5 N square 1 to the power half. Did you get it? Okay. So now third is G. Don't say C. You are not in the first level of Gibbs energy G. G equals to U minus Ts plus PV. Okay. What you got, Panadi? Minus S5 minus S5 by minus S to the power 5 AB N square 4 to the power half, which is nothing but minus U. Equation number B. Now that's the attacking point. You have to express G as a function of TPN. Right? This is now written in terms of s to the power 5 by 2, b to the power half. Then is okay. So s to the power 5 by 2 and b to the power half should be obtained from your, that's what I said that. The slope equation should be target point. If you take the slope equation and target point, it will get a final answer. It will get a final answer. That I won't do it here. You have to go back home and do it. If I do everything here, you won't be able to, you won't be learning. What's the final answer of G? Yeah. G equals to? Just I asked, she is volunteering, so please don't, if you want to prompt, you please raise the hand. Yes, madam. Minus 2t by 5. 5 by 2. What? A naught. That's it. And you can do inverse Fourier transformation from here and you can get there. Did you get it? Okay, good. So if you get it, that means in the exam you are going to crack. This is the toughest problem. The exam problem is easier than this. Okay, now let me discuss one thing, is about the massive function. From here, one can have the massive set. What is the massive set of functions? Massive set is what? Entropy representation, right? I have discussed. Massive set is so this is like your Maxwell's relationship, right? This is Maxwell's relationship based on energy representation. Energy representation. We can also have entropy representation. What we can write? S equals to S at U B N. ds equals to 1 by t du plus p by t dv minus mu by t dn. Next is, I call this as Hm modified function. We don't know about this Hm. This Hm will be what? Hm hat. I was replacing V by P. Here this V should be replaced by so your U is there. V should be replaced by, let's see whether you understood. V should be replaced by here V was replaced by minus P, right? Here V should be replaced by, what's the slope? Corresponding slope of this? P by T, yes sir. And then so dh to the power m is 1 by t du. It should not be changing. It is changing. What will happen? Minus v. Minus v. Differential of p by t minus mu by t dn. Who will get the answer? Can I know the name? Who gave? Yes, thank you. Next is A modified. What is A hat? Who will volunteer? See how it will automatically. A hat will be. So now you can see that enthalpy. So enthalpy function, you can do it. That we will be doing later. A hat. Yes. Again, you what? 1 by t Vn, and differential An equals to U differential 1 by t, right? Minus yes, plus p by t dv, am I correct? Minus mu by t dn. This is is not the exact Helmholtz function because you can see that how that changing. So this is the modified Maxwell relationship based on Massieu function. This is based on Massieu function. Next we can have Gm, which is Gm hat, which is 1 by T, P by T, N and dGm equals to what? Again, minus U differential 1 by T minus V differential P by T minus. Automatically, you don't have to remember anything. Only thing is you have to fill from your heart the Lagrange, the regional transformation. If you know regional transformation, if you can fill from your heart, you can actually get it. I am not remembering anything. Okay? And you have to, your job is to go home and to prove it. And from here you can actually get H function. What is H function? Hm, which is S minus M1 x1. What is M1 x1 here? What is M1? P by T. What is X? V. So you got modified enthalpy S minus P by TV. Earlier it was H equals to U plus TV, and you got here minus P by TV. It is, what is the M? It is minus P by T or plus P by T. Yeah, plus P by T. So it is S equals, earlier it was minus plus, it is minus. So Hn, so you can actually have A also. What is A? A equals to again. So the one is lost. You don't know anything of, yeah, you are not able to say anything. You are just keeping mum. S minus M1 x1, what will be M1, what will be x1? M1 is 1 by T, x1 is U. Am I correct? Here A was U minus Ts. Here it is S minus U by T. G equals to, Gn equals to S minus M1 x1 into x2. Two changes here. What is M1, what is x1? 1 by T. 1 by T. U then P by T. Agreed? Yes. So that's the modified Gibbs function, modified Helmholtz free energy, modified enthalpy representation. Okay, so that's the way entire thing is there. One more thing I actually wanted to discuss. From here, we can write du equals to T ds minus P dv specific variable. From here, we can write dH equals to T ds plus small v dp. From here, you can write ds equals to minus s dt minus p dv, and from here you can write dg equals to minus s dt plus v dp. You know how to prove it? We have done it, this proof, which is this ratio of the, or change of the extensive variable. There is dou u by dou s at fixed b equals to dou u by dou b at fixed s. Same thing. Dou of the small u by dou of small s with respect to fixed b should be equals to dou e capital U, but dou capital S with respect to dou s v n. The same way, if you want, you can go home and try to prove it, and that's very important. I am not going to derive it because already we have done it in the class. The same way, so it is, if given h is equals to Spn, you can actually get small h of is a function of S and P. Okay, so that's the thing, and also another thing I want to discuss. We know that du equals to T ds minus P dv plus mu dn, and mu equals to dou u by dou s, dou u by dou n s. Here dH equals to TdS plus VdP plus mu dN, and mu is here dou H by dou N SP. Am I correct? This is mu U and mu H. So this mu is based on internal energy, mu is based on H. How can you say they are same? How can you say mu U equals to mu H? How can you say they are same? Any idea? How can you derive they are same? It's easy to prove. H equals to plus PV, dH equals to du plus PdV plus VdP. Du expression is TdS minus PdV plus mu u dN plus PdV plus VdP is getting cancelled. dH is what? TdS plus VdP plus mu h dN, which is TdS plus mu u dN plus VdP. VdP cancel, TdS cancel, so it says mu h now. Correct? Okay? So the chemical potential you can express in terms of enthalpy, in terms of Helmholtz energy, in terms of Gibbs energy. For the Gibbs energy, mu is defined as, that is the most commonly definition, dou G dou N Tp. Okay? Chemical potential also, and that's it, which is equals dou U by dou N, dou U dou N SB. So dou U dou N SB. Now we can see that how these quantities are coming. In the books earlier, you are just simply marking, but we can now fill for that. If you fill, you don't have to remember anything. It will come automatically from the bottom of the thought. Okay?
So will mu be the same? I mean, can we get the same relation for the other stuff also, like G, like from G also it's a function of TPN. So
Yeah, that's what dou G dou N Tp.
Okay.
You go back home and try to prove it. Yeah, that's your task. I cannot do everything in the class. That you can do it in the class. Do it. Go back home and do it. Okay. So that completes the Legendre transformation in entire family of the Maxwell's equations. So you can see that how the entire family of Maxwell's equations have come to the Legendre transformation. The first time we have proved it, earlier we did not prove it. The first time. And basic thing is, we have to remember only these two. Everything comes, even the entire Maxwell set will be coming from here. We don't remember anything, we have to remember only this. du equal to TdS minus PdV plus VdP. So, the question is, again I am going back to the more fundamental perspective. What I am trying to say here, that our measured property is temperature and pressure. Even volume also very difficult to measure. For this kind of room, we want to measure it. Really good or hard work to measure the volume. But not volume is also measurable quantity. But the three measurable quantities anybody can do as a chemical engineer: temperature, pressure, and volume. Now, if somebody asks me how my entropy is changing with respect to volume, how my internal energy is changing with respect to volume. You know, internal energy is a function of SVM. How my internal energy is changing with respect to temperature, how to get it? So, a lot of differentiation, lot of checking the functions and all those implicit functions and all those things will be there. So let's look at a procedure. If somebody wants to measure, say for example, dou U by dou T at fixed T, or somebody wants to measure dou S by dou P at fixed T. I want to measure how the entropy is changing with respect to pressure at constant temperature. It is useful. We want to know that. We want to know that, and from that we can actually get the entropy. So if you know the entropy at the standard state at 1 atmospheric pressure and temperature, say 273 Kelvin, we can calculate the entropy. And you remember that we have the steam table where we have the enthalpy, entropy at any temperature and pressure that is dependent on the way this philosophy. So far nobody discussed how to get the steam table. Steam table is available on the market. We actually use sometimes ideal gas. It's wrong. We have to use the real gas equation of state. But main fundamental is, if you want to identify these functions, you can really see how the entropy is changing in temperature, pressure, how internal is changing in temperature, pressure, how the enthalpy is changing in temperature, pressure, or volume, whatever. And based on that, any of your own tables, in fact, you can go and modify your steam table and have your own table based on this mathematical perspective. Let's discuss how to calculate dou u by dou t, where u is the function of Sv. How to calculate Sv, where S is the function of what? UV. It's not even function of, it says the function of temperature and pressure. It suggests that you can be expressed as a function of temperature and pressure. It suggests that S can be expressed as a function of temperature and pressure, but we know this. How? Knowing this to get this one? How knowing this to get this one? If you get this one, then only you can calculate. If you know this one, you can calculate. So we'll introduce the concept of implicit function theorem and chain rule of differentiation. So we'll start with implicit function theorem and chain rule of differentiation. If y equals to fx, can we write x equals to gy? If I can write y equals to fx, can I write x equals to gy? Yes, always. No. Inverse. Reverse, how can you write always? Can you write, think about it. Can you write? What is implicit? I don't know implicit. Did I discuss implicit functions so far? I have not. I have not discussed. I am just going very preliminary level. Don't talk any high fonda. Only high fonda thing we know so far, Legendre transformation. Only that much we have learned so far. Can we write x equal to gy? If I say y equals to fx, that means everywhere the dy dx is defined. The function is continuous. Function is continuous. Okay? So if I say x equals to gy, dx dy has to be defined everywhere. Okay? So if I say x equals to gy, if I want to write dou gy by dou x, dou g by dou y, which is equals to dx by dy. And so whether we can do that, let's see y equals to fx, which is given. This is your given. And dy equals to dou f by dou x dx. Only one variable, no problem. So you can write from here dx dy equals to 1 by dou f dou x. Correct? And this is nothing but dou g by dou y. Now you can see that dx by dy will exist if dou f by dou x non-zero. If dou f by dou x is 0, like this kind of point, where dx dy is undefined. Okay, so for this case, we cannot write x equals to 0. Correct? Correct? Okay. So it is not quite obvious. If y equals to fx, you can write x equals to gy, provided that dou f, dou x or f prime x is non-zero. Very important. Provided it is non-zero. If it is 0, then you cannot write. Now let's go to the two variables. Z equals to x okay. Can we write y equals to gxz? one variable. One independent variable can be write in terms of different variable and another one independent variable. Y equals to gxz. Can you write? Answer is no all the time. What will be the condition? What was the condition? Here the condition was dou g by dou y should be existing. Here the condition will be. Here the condition. So here dou g by only one hand please. Yes.
So dou g by dou z.
No. If you say dou, something has to be constant.
X by x.
Dou g by
dou z.
At x constant. That's all. If I say dou g by dou x at z, why not? There are two independent variables. We are giving only one here. Why not here? So you have to tell two, no? Yeah. Both are not the same, right? They are different. They are different. So dou g by dou z at x and dou g by dou x at z must exist. Try to see what are they. So one case x is constant, one case z is constant. So z equals to f of xy. Same procedure. You write dz equals to dou f dou x at constant y dx plus dou f dou y at constant x dy. If I fix z constant, dou z at z constant, which is dou f dou x y dx dz, sorry, dou x z plus dou f by dou y x dou y z, and dz constant means dz equal to 0, no change of z. So from here we can get interesting formula, which is dou y by dou x z equals to minus dou f by dou x at fixed y by dou f by dou y at fixed s. Very important formula. That means dou y by dou x z is nothing but dou g by dou x z. Am I correct? Dou y by dou x z is nothing but dou g by dou x z, which exists if dou y by dou y at fixed x is non-zero. Which exists if this is non-zero, right? Correct? If this is 0, that is gone. So that means you have to see the dou f by dou y and dou f by dou y at fixed s or dou f by dou x at fixed y. So here for this case, dou f by dou y at x should not be 0. If it is 0, then you cannot write dou y by dou x equals to z. If you cannot write, then you cannot write z equals to or y equals to g of x. Other derivative, dou g by dou x at fixed z. Okay. Next is, again we have to say whether it exists or not. So we can we have to it exists or not. So we have to write z equals to f of xy, and the same thing dz equals to dou f by dou x at y dx plus dou f by dou y fixed x dou z at constant. Next is, we have proved for z. Now this should be constant x, right? Am I correct? So it is equals to dou f by dou x at y dou x x dou f by dou y x dou y x. This will go to 0 because constant x dx cannot occur. So the entire term is going to 0. So we will get dou y by dou z x equals to 1 by dou A by dou Y. So what you are saying is this will excuse me, dou Y by dou Z x will exist if dou A by dou Y and x is not 0. So this is called as implicit function theorem. This is called as implicit function theorem. And thus to summarize the implicit function theorem, one can write in a formal manner. If z equals to z hat xy, and then if you want to write y equals to y hat zx, in that case both the derivative must exist, dou y dou xz and dou y dou zx, and for dou y dou xz it is minus dou z by dou x y by dou z by dou y x. How to remember? You can see that. I don't mug up this formula, there is a way to remember. This z is coming here, so z is coming in the numerator. This x is coming at the bottom, that means it is coming at the bottom. Y is top means it has to be coming to the bottom of bottom so you can go to top, and then y and x, you put y and x. You see how to remember? I don't remember, I only know the rule. Dou y by dou x is nothing but minus dou z by dou x at fixed y divided by dou z by dou y at fixed x. And this is pretty straightforward, which is 1 by dou z by dou y at fixed x. This is just topple, just like. So then now you can see that you cannot write just like that. If you want to write just like your fractional formula, it is wrong. It should be coming from calculus. So calculus is not straightforward. So if you write dou u by dou x, it is not like your 5 by 3. 5 is divided by 3. It is something that is, it says that change of u with respect to change of x, while other variables are constant, and the change of x is tending to 0. In that case, the relative change is termed as dou u by dou x. That's the fundamental of calculus. Okay. Okay. Now let's look at, so we promised what we are planning to do. Now I think we have got our formulas handy, implicit function theorem formulas handy. We know that u equals to u hat sv, and I want to calculate, for example, I want to calculate. Now see how we can apply the formula. It suggests that this should be function of TV, right? This should be function of TV again. What is the original function of SV? Original function of SV. So Z is the function of xy. How to pose it? X is the function again of uv. Y is the function of uv. I have done, I think, in the class earlier, right? That I have done. So what will be your Z? Your Z is Z hat x uv. I can write this as z bar uv. Now you can see z has been function of uv, right? Correct? Now if I want to find out, see now z is a function of uv but not the explicit, implicit, because x is a function uv, y is the function of uv, and z is a uv. It's a parametric representation. Okay? It's a parametric representation. If I want to find out dou z by dou u at fixed v, of course we have to write target from here, like earlier time, right? Okay. What should I write from here? let me start from here. If Z hat xy, if I want to write dou z by dou x, sorry, I just put it as better because I don't want to go to that basic. Dou z by dou u at fixed b from here. What should I write? What is dz? Dz is nothing but dou z by dou x at fixed y dx plus dou z by dou y at fixed x dy. So dou z by dou u b. Now you can tell me. And you are not studying at all. Dou z by dou x at fixed y dx. Dou z by dou y at fixed x dy. I am not taking dou z dou u v. Let's take from there. No answer. I am just giving everything. I am not able to answer that. I am just surprised what I have taught all junk. Yes, madam. Dou z by dou u. I am taking dou z by dou u. Yeah, I will just come here. Should be equals to. Should be equals to. Should be equals to. Very simple thing. Yes.
Dou z by dou x.
Dou z by dou x.
Dou x by dou u.
You have to write, sir, what is constant, no?
And
Why?
X.
And then next,
Dou x by dou u.
dou x by
Dou u.
at constant.
3.
Yes, sir. Then plus other term is there, no?
Dou z by.
It is there. dz. You just see the dz formula. You can get it.
Again dou z by dou y.
Yeah. At
constant
fixed.
x.
Yes.
And into dou y. Dou y by dou u at constant v.
So easy. I am surprised. I think last batch it was not that bad. At least I was getting so many responses. This batch only 1 or 2. I am really surprised. Is it clear to all of you? Yes? Yes. I have done earlier in the class. That means you are not studying, you don't care to study. So, we can write this as dou z. Similarly, we can write dou z, dou vy. Who will volunteer? Who will volunteer? Who will volunteer? Dou z by dou u, dou v at fixed y. Fixed u, sorry. At fixed u.
So, dou z by dou x
Yes.
at y,
Yes.
dou x by dou v
Yeah.
at u,
Yeah.
plus dou z by dou y
Yeah.
at x,
Hmm.
dou y by dou v at u.
Very simple, just following that. Now, coming back to this problem. U equals to u hat SB. I have to write dou u by dou v at fixed t. You can write this as u equals to u hat, s equals to s hat. If you can express in terms of vt and v, your job is done. What should I write then? Dou u by dou v at fixed t. Who will volunteer? Now we have learned this chain rule, implicit function. Dou u by dou v at fixed t. You can write bar. That's our final function. Use the final function of t bar. Yes. If you forget, always try to represent in terms of du, and from there you can proceed. That is better. That's the way I remember. Dou u by dou v at fixed t. Dou u by dou v at fixed t. Anybody can volunteer? The same thing what we have done there. It's so easy.
Dou u by dou s.
Dou u by dou s at fixed b.
Dou s by
Dou s by
dou v.
dou v at fixed
3
plus
plus
dou u bar by dou u by dou v, fixed s,
and dou v by
dou v. So this will go 1, dou u by dou v s. So that's the formula. So dou u bar by dou v at fixed t is nothing but dou u dou s v, dou u dou s v, dou s dou v t plus dou u dou v s. So what will be dou u by dou t v? Quickly, can you tell us? Dou u dou t at fixed v. Quick, I want the final expression. Dou u bar by dou t v. Remember that when I say that means my final function is u equals to u bar tv. My original function, always start with original function sv. Always original function, the first law of thermodynamics, first and second law, and objective is to get tv. That means it has to be coming as t and v, no other value. So we have to express as t and v. That's it, and that is nothing but u bar tv. Now, dou u by dou t at fixed v. If you want to do that, you take the original function, which is based on combined first and second law of thermodynamics, which is du equals to dou u by dou s at fixed v ds. We have done long back, plus dou u by dou v at fixed s ds. If you do that, what's the answer? I'm surprised that so much of hard work I have to do, and to get the answer, unfortunately, I'm not getting. The entire class is silent. I am really a failure in thermodynamics for this batch. Yes, sir.
dou u by dou s
Dou u by dou s at fixed v,
dou s by dou t
dou s by dou t at fixed v plus
dou u by dou v
dou u by dou v
at fixed s
at fixed s,
dou v by dou t
dou t by dou t.
at fixed v.
So what will be this term? 0, because at fixed v. That's the thing. So easy. No answer. You are not studying at all, right? I don't know what you are doing. This whole thing is so easy. It is nothing to remember. Let me just go by logic. Next we will go some of the interesting relationship for the Maxwell's equation. Okay? So for the Maxwell's relationship, we have done it from the combined first and second law. du equals to tds minus pdv. Alternate representation is dh equals to tds plus pdv. dA equals to minus sdt minus pdv. dg equals to minus sdt plus pdv. Am I correct? T is what? Dou u by dou s at v, and minus p equals to dou u by dou v at fixed s. We can write from here dou t by dou to u by dou s dou v, which is dou t by dou v at fixed s. Because you know that dou s is dou u by, this is this, when you take v, it will be s. That's the way my partial differentiation, second order differentiation is defined. Okay. Same thing is, from here what did you get? Dou to u, dou v dou s, which is minus dou p by dou s at fixed v. So you got what? Since this is thermodynamic property, dou to u by dou s dou v equal to dou to u by dou v dou s. So this double derivative will be same whatever way you take it, because the thermodynamic property, which is independent of path, which you have done in first class. Okay, and from here we can get dou t dou v s equals to minus dou p dou s v. Correct? Yes. Yes. Okay, so with that, for each relation, for each combined first and second law, you get 4 equations. What are those 4 equations? We can go home and derive it. equals to minus dou P dou SV. Take up enthalpy equation. T and B. What you do get from enthalpy equation? This equation?
Dou H by dou S.
What is that? Dou H by dou S. No H will be coming. Why H will come here? H will not come. Enthalpy, but it did intermagic again here. Please apply your brain what we have done here. Because what I am trying to do here, H is the function of S and P. What is dou to H, dou S, dou P? And what is dou to H, dou P, dou S? And that should be coming from here. So there should not be any H here. What we have done here? Yes, sir. Dou T by dou P at constant?
Yes.
Yes.
That's all. Dou V by dou S at constant.
Dou P,
Dou V by
dou V by
dou S
dou S,
at constant P.
constant P. Second relation is over. Third relationship. Who will find the third relationship? Third relationship from Helmholtz free energy. Who will volunteer? Yes. Dou S by dou V at constant T. Dou P by dou T at constant V. Last relationship. Minus. Who is? Yes. Minus dou S by dou P. Minus dou S by dou P at constant T equals to dou V by dou T constant T. So these relationships, these two relationships will be using quite often. And from here we can see that S is the function of B and T and S is the function of P and T. So from here one interesting thing we have learned that of course P is the function of T and V. This is coming from equation of state. We know that. PV equals to RT. Classic example is that P is the function of P and T. That is known. Having said that, S is the function of T and V has been established from the Maxwell's relationship, and here S is the function of T and T. Very beautiful. You can see interesting stuff from the Maxwell's relationship is also a consequence of the combined first and second law of thermodynamics that S can be expressed as a function of T and V as well as a function of T and T. Is the conduct clear to all of you? So these are the combined first and second law of thermodynamics. I stop here and the next class we proceed further.